Introduction. The Canadair Regional Jet, CRJ, is a 50-seat aircraft especially designed for the regional aircraft industry. The aircraft's first flight took place on May 10, 1991. A derivative of the highly successful Challenger 601 business aircraft, the CRJ has incorporated a 6.1-meter fuselage stretch and a 1.8-meter extension to the wingspan. The aircraft features a wide-body fuselage with 4 across seating, a quiet cabin, jet comfort, and speed. Aircraft models. The Canadair Regional Jet is available in 2 different series. The CRJ 100 series of aircraft is powered by the General Electric CF34 3A1 power plant. The CRJ 200 aircraft is powered by the CF34 3B1 power plant. The CRJ 100 and 200 series aircraft are available in either a long-range LR or extended-range ER version. The LR version has a higher maximum takeoff weight and greater range than the ER. Aircraft performance. The CRJ is capable of maintaining a cruise speed of up to 0.81 Mach. The aircraft's maximum operating altitude is 41,000 feet. Maximum operating range is specific to the aircraft model. For example, the 200 LR aircraft with 50 passengers on board is capable of ranges up to 2,005 nautical miles (nm) when flown at a normal cruise speed 0.74 Mach. The 200 ER aircraft, when operated under identical conditions, has a range of 1,645 nautical miles. Noise and exhaust levels. The Canadair Regional Jet easily meets the most stringent of the FAA's rating system for aircraft noise as defined by FAR Part 36 Stage 3 requirements. Exceptionally quiet during takeoff and landing, the CRJ has allowed a number of airlines to extend their operating hours at some airports. The engines are highly efficient and clean burning, which leads to very low exhaust emissions and lower fuel consumption. Aircraft dimensions. Caution! Particular attention should be made to wing clearance when towing or taxiing due to the swept back wing and the angle of the winglets. Engine and APU hazard areas. Aircraft construction. Many different types of material are used in the construction of the Canadair Regional Jet. While still considered an all-metal aircraft, composite materials play an important role in the aircraft construction. High-strength aluminum alloys are used throughout the primary structure. In areas that require exceptional strength, titanium is used. Advanced composite materials, including Kevlar and graphite epoxy, are used extensively in areas such as fairings, servicing doors, and secondary structures. Fuselage. The fuselage is an all-metal semi-monocoque structure that is comprised of forward, mid, and rear sections. The fuselage is D-shaped, where the wing attachment is made. Wing. The aircraft wing is an advanced technology airfoil and is manufactured as a single unit. It is bolted to the fuselage at the center box structure. The wing skins are manufactured as 3 machined panels for each upper and lower wing surface. The internal surface of the wing is sealed to form the wet wing fuel tanks. Wing leading edges are polished aluminum alloy and are anti-iced by using engine bleed air. The winglets are mounted at the tips of the wings and form nearly vertical aerodynamic surfaces. The winglets create a forward lift component and a reduction of induced drag that translates into a 3% fuel consumption reduction. Empennage. The T-tailed empennage consists of a vertical stabilizer, elevators, rudder, and a fully movable horizontal stabilizer. Leading edges of the swept-back vertical and horizontal stabilizers are constructed of polished aluminum alloy. Flight controls. The primary flight controls consist of the ailerons, elevators, rudders, and spoilerons. Conventional cables and push rods are used to transmit the pilot inputs to the hydraulically powered ailerons, elevators, and rudder. For roll assist, the spoilerons use fly-by-wire technology and hydraulic actuators. The secondary flight controls consist of horizontal stabilizer, stab trim, aileron and rudder trim, flaps, flight spoilers, ground spoilers. Spoilers. Computer-controlled and hydraulically actuated flight and ground spoilers are installed on the upper surface of each wing. Flight spoilers are used in flight for lift dumping. The ground spoilers are major components of the ground lift dumping system. The ground spoilers, flight spoilers, and spoilerons are automatically deployed during a rejected takeoff or on landing to assist in aircraft braking. Flaps. The flap system consists of electrically operated, mechanically driven, double-slotted flap panels. The inboard panels move through an angle of 45 degrees, while the outboard panels move through an angle of 40 degrees. Horizontal stabilizer trim. The horizontal stabilizer is automatically or manually trimmed through a range of +2 to -13 degrees of travel. Movement of the horizontal stabilizer compensates for changes about the longitudinal axis, brought about by changes in the aircraft's center of gravity. Aileron and rudder trim. To change the neutral position of the control surfaces, electrical motors reposition the aileron or rudder control cables. Landing gear. The landing gear is electronically controlled and hydraulically actuated. Main landing gear, or MLG. The dual-wheel main landing gear is a trailing link style of gear with nitrogen-charged shock struts. Hydraulic actuators are used to extend and retract the main landing gear. The gear retracts inward into the main gear bays. When retracted, the wheels are enclosed inside a protective wheel bin and sealed by an aerodynamic brush seal. Each main gear is equipped with temperature-monitored and anti-skid protected steel brakes. Nose landing gear. The nose landing gear is a dual-wheeled assembly with an over-centering downlock and conventional shock strut. The nose gear retracts forward into the nose gear bay. When retracted, the gear is fully enclosed by a pair of hydraulically operated doors. Nose wheel steering uses steer-by-wire technology. Steering tiller or rudder pedal inputs generate electrical signals to hydraulically turn the nose wheels. CF-34 power plant. The aircraft is equipped with two fuselage-mounted General Electric CF-34-3A1 or 3B1 high-bypass turbofan engines. The CF-34-3A1 and 3B1 engines are identical in appearance and operation. The 3B1 model has been modified internally to provide better flat-rated power availability and lower fuel consumption. The engines have a normal takeoff thrust rating of 8,729 pounds. When the automatic performance reserve system is activated, engine thrust is increased to 9,220 pounds. Lightweight clamshell cowlings provide maintenance personnel with quick and easy access to the engine. Engine major assemblies. The CF-34 power plant is comprised of the N1 and N2 sections. The N1 section consists of single-stage fan and is driven by a 4-stage low-pressure turbine assembly. The N1 fan generates 80% of the thrust at takeoff. Fan discharge air can be reversed during an aborted takeoff or on landing to assist in stopping. Engine services. In addition to producing thrust, the engines provide AC electrical power, bleed air, and hydraulic power to operate various aircraft systems. A 30 kVA AC generator and a mechanically driven hydraulic pump are mounted on the accessory gearbox of each engine. 10th and 14th stage compressor bleed air is used to power pneumatically operated systems. Ground handling servicing points. The location of the ramp servicing points permits quick aircraft turnaround. Most of the service locations are on the right side of the aircraft. This configuration allows boarding and deplaning of passengers while servicing is carried out. Aircraft servicing panels and hatches. Various panels and hatches provide easy access to the equipment located in externally accessed compartments. Unpressurized fuselage compartments include the aft equipment bay and the forward nose compartment. Additional electronic equipment is housed in the pressurized and ventilated avionics bay located beneath the fuselage floor. Maintenance servicing points. Maintenance service points are also located in easily accessible locations. Maintenance servicing points are located at external fuselage panels, nose area, aft equipment bay. Doors and emergency exits. The passenger door is the main entrance exit for passengers and crew. A service door is provided at the galley for loading and unloading of passenger meals and serving equipment. For emergency ground evacuation, the CRJ has 5 emergency exits. They are passenger door, service door, overhead escape hatch, left overwing emergency exit, right overwing emergency exit. All hatches and doors can be opened from either inside or outside the aircraft. Passenger door. The passenger door incorporates integral stairs and folding handrails. It is counterbalanced for ease of manual operation. The door can be raised electrically to the closed position. Service door. Galley servicing is carried out through the service door, located on the forward right side of the aircraft. The door opens outwardly and in a forward direction. Escape hatch. A hinged overhead escape hatch is located in the flight deck. It provides the pilots with an alternate escape path. Overwing emergency exits. 2 overwing emergency exits are provided for passenger evacuation. Cargo compartment. A ventilated Class C cargo compartment is located behind the passenger cabin. Optional air conditioning is available. 2 smoke detectors and a fire extinguishing system protect the cargo compartment. The compartment can accommodate up to 3,500 pounds, 1,590 kilograms of cargo. The compartment can be accessed through an external door.